It's sheep shearing time on Tom and Jerry's ranch. Today they sheared 1/4 of their herd. Tomorrow they will shear 1/5 of the remaining sheep. By the end of the workday tomorrow, what portion of the sheep will have been sheared? And just in case you don't know, shearing is when you kind of shave the sheep and take off all the wool, so then you can take the wool to the market or whatever, and they can weave it into some sort of textile that they can make clothing out of or something out of. So we're going to try and find the total that will be sheared tomorrow, at the end of tomorrow. So what we're going to need is we're going to need 1/4 of the herd, and we're going to need 1/5. And what we're going to do is we're going to combine those, because this is sheared today and this is sheared tomorrow. So we're going to take 1/4 plus 1/5. Now, as you notice, boys and girls, are we speaking the same language here? 4 and 5. No, we're not. So we have to make sure we have to translate so they're speaking the same language. And what we're going to do is we're going to think about where 4 and 5 meet. And well, the easiest way to look at this, boys and girls, is by combining the two together. So 4 times 5, where do they meet? They're going to meet at 20. At 20. That's their common language. So the question being then, what did we do to 4 to get to 20? Well, we times it by 5. Whatever I do to the bottom, I'm going to do to the top. 1 times 5 is 5. What did I do to 5 to get to 20? I times it by 4. Whatever I do to the bottom, I'm going to do to the top. 1 times 4 is 4. Now, boys and girls, now that we've translated these, we can get rid of these. Okay, because they were speaking different languages. Now, I can add 5/20ths and 4/20ths. We know that our denominator is going to be 20ths because that's the language we're speaking. Now we're going to add 5 plus 4, and we're going to get 9. So 9/20ths of the herd will have been sheared by tomorrow. Okay, so hopefully this makes sense in terms of we take our uncommon, our different denominators, we find a common language. In this case, 4 times 5 is 20, and then that's what we use. And once we get them in the same language, then we're able to add them. Remember, when we add, we just move our denominator over, and then we take our numerators and add them together. Alright, so let's look at some problems here. We'll do a couple more problems together, and then I will give you a couple problems to work on for kind of your practice. First one we're going to do is we are going to do 1/2 plus 1/4. Okay? Now, notice right away, boys and girls, different language, different language. So we have to get them so they're speaking the same language. And what we're going to do is we think, where do 2 and 4 meet? Well, 2 will meet, they'll meet at 4. So I can leave this one the same, but 1/2 we're going to convert to the language of 4. And we're going to add to that to 1/4. And 1/4 can stay the same because it's already in the right language. So what did I do to 2 to get to 4? Well, I times it by 2. Whatever I do to the bottom, I'm going to do to the top. 1 times 2 is 2. And now I can get rid of this because I've already converted it. Now I'm ready to add. My denominator just slides across because now they're the same. Now I add my numerators. 2 plus 1 is 3. So 1/2 plus 1/4 is 3/4. Alright, your next problem, let's look at 2/7. 2/7 plus 1/3. Okay, now different language, right? 7 and 3 are different. We have to figure out where they're going to match. Well, they're going to match at 7 times 3, which is 21. Now, ladies and gentlemen, do you notice how much multiplication we are doing here? That's why knowing your multiplication facts is so vital to this process. So I'm going to write my 2/7, write my addition sign and my 1/3. And where did they meet again? Well, 3 times 7 is 21. So my common language is going to be 21, and I'm just going to write that there right now. Okay? What did I do to 7 to get to 21? Well, we did it right here. We multiplied it times 3. Whatever I do to the bottom, I'm going to do to the top. 2 times 3 is 6. I can cross this out because I've changed my language. Now, what did I do to 3 to get to 21? I multiplied it by 7. Whatever I do to the bottom, I'm going to do to the top. 1 times 7 is 7. Now, same language, so now I can add them together. 21, because my language isn't going to change. Now I can add my numerator. 6 plus 7 is 13. Alright, so we're about at the 5.5 minute mark of this video. So what I'm going to do is I'm going to give you 2 problems to work on. Okay? The first problem is 4/5 plus 2/3. And your second problem is 3/4 plus 1/8. Alright, ladies and gentlemen, take some time, solve these problems, and then when you're done, restart the video and check and see how you did. Here we go, ladies and gentlemen. The first thing we need to do is we need to get these two talking the same language. 5 and 3, where are they going to meet? Well, they're going to meet when we multiply them, and they're going to meet at 15, because 5 times 3 is 15. So I'm going to, and this is going to be 15 plus 2/3, and we're going to convert that to something over 15. So what do I do? How did I get from 5 to 15? Well, I multiplied by 3. Whatever I do to the bottom, I do to the top. 4 times 3 is 12. Excellent. 3 to 15, I multiplied it by 5. I'm going to do the same to 2. 2 times 5 is 10. Now, I've already changed the language, so I can cross these out because I'm working with these now. My denominators are the same. I have the same language, so I can just transfer that over. And now I'm adding my numerators. 12 plus 10 is 22 over 15. Now, the answer right now is an improper fraction, which I can leave it, or I can make it neater. And the question is, to make it neater, how many 15s can I take out of 22? Well, 22 minus 15, it's going to be 7. So it's going to be 1, 7, and 7/15. Okay? So that's your answer. Either one of these answers is okay, unless they tell you to simplify, or they tell you to put it in a mixed number, or they leave it in an improper fraction. But that's one of those things that you as a student have to read the directions. Alright, so now we have 3/4 plus 1/8. Right now we have two different languages, don't we? Fourths and eighths. So we have to make sure they're talking the same language. The question is, where do 4 and 8 meet? Well, hopefully you see right away that they're going to meet at 8. So let's get them speaking the same language. So I'm going to have 3/4, and I'm going to change it to the language of 8 plus 1/8, and I don't have to change 1/8 because we're already talking eighths, aren't we? So what did I do to 4 to get to 8? I times it by 2. Oops, I should probably switch colors here so you guys can see. Whatever I do to the bottom, I do to the top. 3 times 2 is 6. Now I have 6/8 plus 1/8, same language. Check. Are we ready to add them? Yes. First thing we're going to do, we have our denominator. Our language is eighths. And now we're going to add a numerator. 6 plus 1 is 7. So our answer is 7/8. Alright, boys and girls, sorry that this video and the next one is probably going to be a little bit longer than normal, but it's hard to really explain this process without going through. So hopefully you understand, and that's how we add fractions with unlike denominators. Next video will be about subtracting fractions with unlike denominators.